Hello and welcome to our final practice video for the basic EKG interpretation crash course as part of the EMS Peers YouTube channel. So just some quick information before we start here. This is just a self-assessment to see if you understand all the stuff that was presented in each lesson, and it should give you a pretty good idea of how well you'll do in an actual EKG course or whatever part of your school that you're doing EKGs in. This will help you to determine how well you understand it. And obviously just make sure that you understand all the information. You've done either all the videos in this course, or you've finished reading your textbook, or done all the assignments in your class or whatever. Make sure you've done all that before you watch this video, because it'll be more beneficial to you and you'll get more out of it if you've already done that, instead of coming in and trying this and then going back and learning. Just because it's a mixture of all the things, it's not going in order of each topic. It's just a mixture of every type of rhythm together, so you're not gonna get as much out of it if you're just watching it and then going back to whatever part of the book you're in or whatever. So just make sure you finished all that up and you think that you understand it well enough before you move to this. So these are just reminders. I've said quite a few times that you should follow whatever your school's teaching you or whatever your book says, and you should. It's just this is the way that we learned it in these crash courses, these steps right here, and that's the way that I'm going to go through them in this video. But if you have a different way of doing it, that's fine, just as long as you get the same information from looking at it as I will go over. That's fine. But this is just a quick reminder. Write these down if you need to, if you haven't memorized them, which you should have, because this will be what we're looking for. And then last instructions, as we go through this, each slide has 3 different tracings on it. So first, pause the video and with your piece of paper write down your answers to all 3. That includes the 5 steps of the interpretation, so like the regularity, the rate, all that stuff. Make sure you answer all that for each of the 3 tracings on each slide. And then once you do that, play the video and compare your answers to what I say. Alright, so go ahead and pause the video here. And now you should have answered all the stuff on these, so we'll go over them and I'll break them down. So for this first one, if we check the RR interval for regularity, that looks pretty regular to me. And if we check the rate using the dark line method, which that second R wave looks like the best one, it's the one that's closest to the dark lines. So counting from there would be 300, 150, 100, 75, 60, 50, so it's a little over 50. And then if we use the other method where we count all the complexes in this 6-second strip and multiply by 10, we would have 1, 2, 3, 4, 5, which would equal 50. So that's about what we got with the other method, so I'd say this is somewhere around 55 probably. So next we're going to check our intervals, we're going to check for P waves. So in this there actually are P waves, but if you notice they're inverted. So automatically, and this is in lead 2, so automatically with inverted P waves we know this is not a sinus rhythm. So now we'll go on to our intervals. We'll check our PR interval, which we check this one right here. It's about, let's say it's about 0.08 seconds. So it's shorter than what we'd expect. The big thing is that it's not too long, but it is short, so that does help us to figure out what this might be, because that gives us some clues. And then our QRS complex, going from the beginning of the R wave to the J point, which is like right here, that is about 0.08 seconds as well. So our QRS is within normal range, which tells us that this is coming from above the ventricles. The impulse or the pacemaker that's generating this rhythm is coming from above the ventricles. So what that means, with an inverted P wave, a narrow QRS complex, and a rate of, we decided on, I believe, 55, that would mean that this is a junctional escape rhythm. Because remember, with junctional rhythms, if you do see a P wave, it's going to be inverted because it's lower in the atria, so there's retrograde conduction, which makes the P wave negative. And because it's originating in the junction, the electrical impulse, that means that simultaneously the impulse is spreading the other way and going down through the ventricles. So because of that, it causes the short PRI. Now on the second one here, that looks irregular to me, because if you look at the space between here, then a bigger space there, and there's a bigger one there, and there's a pretty short one there and there, that's what would tell us this is irregular. So we can't use the dark line method to calculate the rate. Instead, we have to count how many QRS complexes there are. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and maybe 12. I don't know if I'd count that one, but so that's going to be about 110 to 120 beats per minute for our rate. P waves with this, there aren't really any discernible P waves. We just have a bunch of gunk down here, just wiggly, hard to discern lines. So we're going to say no P wave on this. Our QRS is about 0.04 seconds, so it's a narrow QRS. So the electrical impulses are coming from above the ventricles. And with that, we can say that this is atrial fibrillation. And we would call this either uncontrolled AFib or AFib with RVR, meaning rapid ventricular response. Now, number 3 down here, that, I mean, you could, if you wanted to see if it's regular or irregular, you could say it's regular, I guess. I wouldn't really, when you see something like that, I wouldn't worry too much about that. Rate, we can't really tell. You could try if you wanted to by like going down here and counting those, or counting the top of these, but it'd be hard to tell, honestly. So we won't do that. No P waves that we can tell, and we can't check our PRI. Our QRS we could try, but it would be kind of difficult as well because we don't know where it starts, where it ends. So for this, I would call this one ventricular fibrillation. And that might be kind of confusing because it also could look like VTAC with the way that it's kind of, it looks, I mean, it looks fairly monomorphic, meaning all these look kind of the same. So you could argue that it's VTAC probably. I say course VFib though, but a way that you would know for sure, or at least you'd be able to rule out VFib and rule in VTAC, would be to actually feel for a pulse, or if your patient's conscious. If they're conscious, you automatically know it's not VFib, because VFib is only a cardiac arrest rhythm. So if they're conscious and you see this, then it's probably VTAC. If they're unconscious, feel for a pulse, because you have to do that anyway to confirm. If you do feel a pulse, then that's again VTAC, because VFib will not have a pulse. Other than that, if there's no pulse with this, I would just consider it to be VFib, and it would be coarse VFib. Alright, pause the video. And now for these ones, this top one, number 4, this is going to be pretty regular. If we look at the distance between there, and then to there, and there, all this seems pretty regular or equal in distance. So we'll call that regular. Our rate, if we do the dark line method, starting from this little point right here with just the one little square left, we go to this one, 300, 150, 100, 75, 60, 50, 40 about. And then if we actually count these and do the multiplication method, 1, 2, 3, 4, that's also 40. So we'll call the rate 40 here. There are no P waves, and so therefore we can't get a PRI, but our QRS complex is pretty wide. So what that tells us is this is something that is originating down in the ventricles rather than up in the atria or sinus area. So the wide complex tells us this is ventricular. And with knowing that we don't have P waves, it is a very regular rhythm, as ventricular rhythms usually are, and it's within the proper rate. With all that, we can determine that this is most likely an idioventricular rhythm, or idioventricular. Then on this next one here, that right there, we don't know if it's regular or irregular. There's nothing going on there, so we can't say. There is no rate, and there's no P waves, no intervals. So based on that, we would say that this is asystole. So a flat line, it means there's no electrical activity in the heart at all. Now this one down here, that is irregular, and we have a rate of about 40. And we do have P waves, but we have some extra ones, as you can see. Well, just one extra, I guess, so we can see for certain here. But no missing ones. And they all do appear to be monomorphic, or coming from the same area. And they appear to be fairly sinus in nature to me. Our PR interval, so from here to there, and looking at this one, and then right there, that's a varying PR. We can tell that over here it's a lot longer, over here it's extremely short, and then this one doesn't even generate a QRS. So we have a varying PRI. Our QRS is, let's say, about 0.08 seconds. So with that information, we could call this a sinus bradycardia with a second degree type 1 AV block. Alright, pause the video. And now we'll talk about these ones. So up here, this looks pretty regular to me. If we use the dark line method, we've got 300, 150, 100, 75, so it's over 75, probably around 80 or so. If we do the other method, the multiplication method, we have 1, 2, 3, 4, 5, 6, 7, 8. So that also gives us 80, so we'll go with 80 as our heart rate. We do have P waves. We have one before every QRS, no missing or extra ones. They are upright, fairly round, and lead 2, and they do appear to be unifocal or monomorphic, meaning they have the same appearance, so they are coming from the same area. So I would call this sinus P waves. Our PR interval is about 0.20 seconds, so about 5 small boxes. So it's not quite an AV block, it's borderline, but not enough that I would call it that. So with all that, I would say that this is a sinus tachycardia, and you could say borderline first degree AV block if you wanted to, but the main thing is that this is a sinus tachycardia. Now with this one down here, we shouldn't really have to go through all the steps, because there should be something that stands out to you that makes you realize that all the steps aren't really necessary. But if you don't see that and you end up going through it anyway, we would determine that this is a regular rhythm. It's at a rate of about 2, 3, 4, 5, 6, 7, 8, maybe 90, 80 to 90. We can't see any P waves really, so we can't get a PRI. Our QRS is wide. And then the biggest factor in this one, in deciding what it is these little extremely vertical dark lines right here that we see that don't look like any wave that we know of. Those are pacer marks. So therefore this isn't any type of rhythm. We wouldn't name it anything. We just call it a paced rhythm. And because of that wide complex that comes after the pacer spike, whoops, like that, that tells us that this is a ventricular pacemaker. And it is functioning normal. We don't see any failure to capture or malfunction. So it's a normally functioning ventricular pacemaker. And so it's a paced rhythm. Then this next one down below, this also actually looks pretty regular. So we have R waves there, there, and there, and the distance between them all seems pretty regular. With all these other waves, it's kind of hard to tell where the R wave is sometimes, but if you look closely you can figure out where it is, and it does look regular. The rate is about, let's see, using this one, it's about 300, 150. Yep, just 150, maybe a little bit over. If we count and do the multiplication method, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15. So yeah, about the same. So we'll call this a rate of 150. We do appear to have P waves. These little things right here, they're very pointy and almost sawtooth in appearance. PRI, we could get it. I wouldn't really worry about it in this though. It's not super important. But our QRS is narrow, or not wide is the main thing, so that tells us this is coming from above the ventricles. So with that information, we would call this atrial flutter with a either 4-to-1 or 5-to-1 ratio. And pause the video. Alright, so now, this top one here. Irregular? Yeah, sure. Rate? We can't determine that. There are no intervals. And with that, we can say that this is ventricular fibrillation, and that's coarse VFib, because of how wider would be the word, I guess, how much wider these squiggly lines are, as opposed to it being, whoops, kind of like that. Oh, that was a terrible drawing, you see. As opposed to it being like that, it's more like that. So that's what makes it coarse VFib. Now, the second one, hopefully now, you will have this one down too. So we don't need to go through the interpretation steps because of these little vertical dark lines right here. So once again, we have a ventricular pacer, because right after it we have this wide QRS looking thing. And with this, it does look regular, and there doesn't appear to be any failure to capture or malfunction, so it's a normally functioning ventricular pacemaker. Down here we have an irregular rhythm at a rate of about 40. We do have P waves, but we have extra ones. They are upright, round, and monomorphic in lead 2, so that tells us they likely are sinus. And our intervals, if we look at our PRI, our PR interval is about 0.16 seconds, and it is consistent with all the ones that have QRSs after. So consistent QRS, PRI, our QRS is within normal range at about 0.08. So the only abnormal thing is all these P waves here that don't generate a QRS, but all the ones that do have QRSs have a consistent PRI. So that tells us this is a sinus bradycardia possibly, or some sort of sinus rhythm with a second degree type 2 AV block. And the reason I say possibly sinus bradycardia is because we don't know if it would normally be that slow or whether it's just slow because of this interruption of P waves here. So instead of calling it anything, I would just say that it's sinus and that there's a second degree type 2 AV block. Alright, so now for this one, it is irregular because if you look here to here and then at like this one or this one, it's quite a bit different in length or in space between them, so that's irregular. So we can't use the dark line method, so we count the QRS complexes or R waves. 1, 2, 3, 4, 5, 6, 7. So that's a rate of about 70. No discernible P waves, so we can't get a PRI. We have a narrow QRS, about 0.04 seconds, which tells us this is coming from above the ventricles. And with that we can determine this is atrial fibrillation or AFib, and this is controlled because it is under 100 beats per minute, so this is controlled AFib. Down here, we can't determine regularity, there is no rate, we can't determine intervals, and based on that we can call this ventricular fibrillation or VFib, and this one is more of a fine VFib rather than a coarse one. It might be coarse just going into fine, but it's definitely more fine in appearance than coarse VFib. Down here, this looks pretty regular. If we use the dark line method, our rate is 300, 150, 100, so it's about 120. And now if we use the multiplication method, 1, 2, 3, 4, 5, 7, 8, 9, 10, so it's somewhere between 100 and 120. We do have P waves, however, like this one looks a lot different from this one, which look a lot different from like this one and that one. So we have P waves, but they are kind of odd in appearance, they're different. So it's kind of tricky to say. So like the thing that would be hard with this to determine is the fact that they appear to all be positive and upright facing, so it doesn't appear to be an atrial thing so much, but at the same time with the different appearances like that it still can be. So what's important to remember is that atrial P waves don't have to be inverted. I would expect to maybe see one or two that are in here, but it doesn't have to be, because if it's close enough to the SA node it'll still be a positive upright deflection, but there is some varying appearance. So because of that, I would say, and you know, it's one of those things that comes with experience, so I would be fine with calling this a sinus tachycardia, honestly, just because it's not very irregular. However, you could also call this wandering atrial pacemaker, and that would probably be justifiable too. It's just with experience, you kind of, even when there are slight variations in P waves, you learn when to tell when it truly is because of a changing pacemaker site, or whether it's just one of those things where it just looks weird for no real reason that we would be able to tell. So you could call this either one. Sinus tachycardia possibly, most likely maybe, but I think for this we'll call it wandering atrial pacemaker. And if you notice, we do have these weird little dark marks in here, which could confuse you and make you think that this is a paced rhythm. But here's why it's not, is because we do obviously have P waves, so we know it's not a atrial pacemaker, which would mean it has to be a ventricular one, and it does come before the QRS. But all these QRSs are narrow complex, so they're not wide, which they would be if it was a pacemaker. So that's what tells us this isn't a paced rhythm. It's just some weird artifact or something else in there. So pause the video. Alright, so for this one, the top one, yeah, you could say maybe regular or irregular. I'm not too worried about its regularity with this one, at least. It's kind of hard to tell for sure. Also with the rate, I'm not too worried about that. You could check it if you wanted to. It is closer to the 300 range, about. No P waves that we can tell, so we can't check a PRI. The QRS it's a little wide, and in some areas it doesn't look so wide, but there is definitely a changing pacemaker location. So the biggest thing to take into consideration here is right here it looks like they're all negative, pointing downwards. And then right here it kind of transitions, and then it's facing upwards. And right there it kind of transitions back into downwards. So the R wave, or the peak of the complex, goes from here up and then back down. And then the other end of that goes from here down and then there. So it's kind of stays somewhat in the same place, like right around the isoelectric line, but this right here and right there, it kind of twists between positive and negative. So if we remember what stands for twisting points, that would be torsades. So this is torsades de pointe, or twisting of points, is our rhythm. This next one looks pretty regular to me. Dark line method would be about 300, 150, 100, so again about 110 to 120. If we do the multiplication method, we have 1, 2, 3, 4, 5, 6, 7, 8, so about 80-ish. So it's on the higher end of normal, maybe a little bit above. That's alright. But the key thing here is when we look for our P waves, you might think there aren't any, and that might be the case, but I think there are, and these right here are actually inverted P waves. And some people might look at it and think that that's a Q wave. I just think they're P waves, and that just, again, comes from experience and just the way they're all shaped. It just stands out to me more as a P wave. But either way, whether we determine that those are P waves or we decide they aren't, it's not going to change our end result or what we determine this rhythm is. So it doesn't really matter whether you think those are P waves or Q waves. Just be able to justify either way, just for the sake of learning, but it really doesn't matter in the end, and we will come to the same conclusion. So checking our PRI, it is short. Our PRI on this is about maybe 0.08 or just over 0.04. So we have a short PRI. Our QRS complex is about 0.04, so it's narrow, so it's not coming from the ventricles. So it'd be above that. But with our P wave being inverted, if that is a P wave, that tells us it's somewhere in the low atria because it's doing retrograde conduction. So if we have something that's not going or not starting in the ventricles and not starting anywhere in the high atria or sinoatrial node, all that would leave is something that is in the junctional area, the AV junction. And with a rate of about 80, I think is what we decided on, about, that would mean that this rhythm right here would be an accelerated junctional rhythm, because we have inverted P waves, a narrow or regular QRS, and normally junctional rhythms, those would be at a intrinsic rate of 40 to 60, I believe. So it's faster than that, but it's not junctional tachycardia, which would be a junctional rhythm that's faster than 100. So therefore this is an accelerated junctional rhythm. This one down here is irregular. We have a rate of about, I guess you could count that one, I don't know, but we'll go for it. 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we won't count that one because we can't see all of it really. So a rate of about 140. Our QRS is within normal range at about 0.08. No P waves from what we can tell. No PRI, and we already did all that. So now we can name it. This is a atrial fibrillation with RVR, meaning rapid ventricular response, or uncontrolled, because it is over 100 beats per minute. So uncontrolled AFib or AFib with RVR. Pause the video here. Alright, and now this one, it is irregular because you see the space from here to there and there is fine, but then we have this huge space right there. So this is irregular. Rate would be 1, 2, 3, 4, 5. So a rate of about 50 beats per minute. We do have P waves. There is one before every QRS, but there's also an extra one right here. So with that, they do look like they're coming from the same pacemaker. They're monomorphic, upright, round, and lead 2. Our PR interval is about, let's say, 1, 2, 3, 4, maybe 5, and it looks pretty consistent across. So then we have a narrow QRS, so it's not coming from the ventricles. So everything is fine except for, again, this P wave right here. All our PRIs here are consistent, but because of that, we could call this a sinus rhythm with a second degree type 2 AV block. And you could say this is a sinus bradycardia just because of the fact that there's only these 5 complexes. However, if this were to generate a QRS right here, that would make the intervals pretty normal, and then it would be 1, 2, 3, 4, 5, 6. So then it would be a normal sinus. So chances are this is a normal sinus rhythm. It's just the regularity and rate are affected by this non-conducting P wave. But either way, I would just, instead of naming it sinus or normal or anything like that, I would just refer to it as a sinus with second degree type 2 AV block. This next one down here looks regular and a rate of about 40. We do have P waves that are unifocal or monomorphic, and they appear sinus. Our PR interval is about 0.16, maybe 0.20 seconds, and our QRS is really narrow, like 0.04 or less. So with that, that would tell us that everything is really normal except for the rate. So this is a sinus bradycardia. This one is irregular at a rate of about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So a rate of about 140. We have no discernible P waves, so no PRI, a narrow QRS. And based on that, we can call this AFib with RVR, or uncontrolled AFib. Alright, this top one here looks pretty regular. We have a rate of about 300, 150, so just under 300 about. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, So this would be a rate of about 210 by that method, so very fast. And with this, there are no P waves, so we can't get a PRI. The QRS appears to be pretty wide. Chances are this person doesn't have a pulse. They might, but I would call this ventricular tachycardia. Now down here, this does look regular from what I can tell. And this one is another one that's a little tricky because it's hard to discern R waves from really tall P waves. So here's the areas where our R waves are. So that looks fairly regular, or regular enough at least. And our rate would be 300, 151, about 100. And if we count these and use the multiplication method, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 100 is pretty spot on. We do have P waves, as we said. There is one before every QRS, but there's also all these extra ones. And our QRS itself is within normal range. It's narrow at about 0.08 seconds. So 1, 2, 3, 4, 5, 1, 2. So I would call this one atrial flutter with a 5-to-1 ratio. Now this next one, this is another one that we shouldn't have to go through the interpretation steps because we should see what it is immediately. This is a paced rhythm because we have these vertical, weird dark lines. Except with this one, we also have narrow QRSs, which tells us it's not a ventricular pacemaker. And we also do see this P wave after these. So what this tells us is this is a atrial paced rhythm, or an atrial pacemaker. And it does appear to be functioning normally. There's no failure to capture or issues with malfunction or it firing in inappropriate places. So this is a normal functioning atrial pacemaker, and we'd call it a paced rhythm. So pause the video here. Alright, so this one is irregular. So we have a rate of 1, 2, 3, 4, 5, 6, a rate of about 60. We do have P waves, however we have an extra one right here. Our PR interval is varying, so right there it's really short, however like over here it's really long. Our QRS complex is about 0.12 seconds, so still normal, but kind of on the wider end of normal. And so with that, what I would call this is I'd probably call it a sinus rhythm, even though those look like pointy P waves, just because they're unifocal, and again, just with experience, I would call them sinus, honestly. So this is probably a sinus rhythm, but we have a second degree type 1 atrioventricular block, which is affecting regularity. Down here, this looks pretty regular, as most super fast rhythms do. Our rate is about 300, over 150, so between 300 and 150. And this says, if we count using the multiplication method, 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this says, when we do the multiplication method, a rate of 200. So very fast. We can't tell if there's P waves in there. There might be. So we can't get a PRI. QRS, though, is narrow, so that tells us it's not coming from the ventricles. So with that, because we can't tell, we would call this SVT, or supraventricular tachycardia. Now this one down here, this also looks to be pretty regular, with a rate of about 300, with a rate just over 60, and we have 1, 2, 3, 4, 5, 6. So we'll just call it 60 because it's around there. We do have P waves. There's one before every QRS with no extra or missing ones. Our PR interval is a little bit on the longer end, but still within normal at about 0.20 seconds. Our QRS is within normal range at about 0.08 seconds. So with that, we would call this a normal sinus rhythm. And pause the video. Alright, now with this one, we have, let's say, irregular because there's a pretty big gap there, and then a smaller one there. That one's kind of somewhere in between. That one's also that same length about, but it is irregular. So our rate would be 1, 2, 3, 4, 5, 6, 7, 8. So our rate's about 80. And then we have no discernible P waves. I mean, that looks kind of like one, but we can't say for sure. And that looks kind of like one, but the rest of these, there's these ones that look kind of like P waves, but there's also a lot of other stuff going on, so it's kind of hard to tell for sure. And then like with this, that might be a P wave, or maybe that's an inverted one, or maybe that's an inverted one and that's an extra one. It's hard to tell. So with these, I would just say there aren't any, so we can't get a PRI. And our QRS is narrow, so it's coming from above the ventricles. So I would call this atrial fibrillation. And let's see, 1, 2, 3, 4, 5, 6, 7. And sorry, I forgot what our rate was. So yeah, about 80. So this would be a controlled AFib. And then if you notice here, and maybe there, but especially here, that looks like a pacer because it looks pretty vertical, but if you look really closely, it's not totally vertical like that. There actually is a little bit of a point, so it's actually kind of like that. It's just really narrow, but it's not completely vertical like this, so that is not a pacer. Now on this next one, that looks maybe it's irregular because we have a space there that's pretty close. Same with there and there, and these ones are a little bit wider. There, maybe there. So we'll call it irregular. I wouldn't worry too much about the rate, but it is fast. That's all we need to worry about here. There's no PRI. Our QRS looks wide. And it starts really tall here, and then if you notice it gets smaller here, and then we can't see it here, but I bet somewhere around here we have a twisting where these then become more negative. So this right here would be torsades. Then with this one here, that looks pretty regular to me. We have a rate of about, let's see, I guess let's use this one, I guess. So 300, 150, 100, 75. So between 75 and 100. If we do the other method, 1, 2, 3, 4, 5, 7, 8. So we'll go with a rate of about 80. There are P waves. We've got one there, and there, 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 and there. They do appear to be unifocal or monomorphic, so coming from the same area. They're upright, round, and symmetrical and lead 2, so these are sinus P waves. Our PRI would be about 0.20 seconds, maybe 0.16. So on the longer end, but still within normal. Our QRS is narrow and within the normal range at about 0.08. So with that information, we would call this a normal sinus rhythm. And there's just some artifact, which is what all these extra weird little wobbles are. It's not really anything significant, it's just artifact. Alright, and we're almost done. I think we have, after this slide, we have 2 more, I believe, or maybe just 1 more. We'll see. So this one is irregular at a rate of about 1, 2, 3, 4, Rate of about 70. We do have P waves. There's one there. That's actually a P wave, even though it doesn't look like it. So is that one. So we do have P waves. There's one before every QRS. No extra or missing ones, but they do not look the same. Our QRS is narrow and within normal range at about 0.08. So with that information, I would call this a wandering atrial pacemaker because it is irregular and we have these changing P wave morphologies. So wandering atrial pacemaker is what I'd call this one. This one down here looks pretty regular, except we have this huge complex here which affects our regularity. So technically it's regular, but for the sake of this you could call it irregular if you want. The rate is about 60, maybe 70 beats per minute, so that's normal. We do have P waves. There's one before every QRS with no missing or extra ones. And they look fairly monomorphic or unifocal, so same pacemaker. Our PRI is about 0.16 seconds, and our QRS is about 0.08 seconds. And then there's also some artifact, just like in the one on the previous slide. So with that information, we could call this a normal sinus with a premature ventricular complex, because we have this wide complex that's going in a different direction from the rest of these. So that's a PVC, premature ventricular complex. The rest of the rhythm, normal sinus. Now this one down here, we have, it actually appears to be regular, and I'll explain why in a bit, but I think this is regular. Our rate is about, that's more, I guess, if we use the multiplication method, it's about 20. So it's very slow. And we do have P waves, so these are actually P waves. You might be mistaking them for just hard to see ventricular complexes. But remember, these right here, these aren't going to be PVCs really if these were ventricular complexes. So this right here is a ventricular complex, a premature ventricular complex. So that means these aren't, and these do, once you look at them close enough, look more like P waves. So we do have P waves. We don't have necessarily one for every QRS. You could say so, like this one for that and this one for that. We do have extra ones, but the main thing here is that they're present. And so our PR interval, there actually isn't one. You might think that this is a varying PR interval, but it's not, and we'll get to that in a second. Our QRS is wide, which tells us that it's originating in the ventricles, which is weird because we have P waves. So if we have P waves, you wouldn't expect to be seeing wide complex QRSs, because that tells us that the impulse is originating in the ventricles. Yet we have upright P waves, so there's no retrograde conduction. So that's kind of a weird thing. But once we go and we measure the PP interval, so interval between P waves, that right there, and there's probably one that's lost somewhere in here in the QRS. So that's a pretty regular PP interval. And then if we check our QRS, it's hard to tell because we only have two QRSs here. But there probably is one like just before this strip around here. So the QRS is probably regular and the PP interval is regular. That tells us that there is both a impulse originating in the ventricles and in the atria. And the issue here is that the atria and ventricles have no organization, or they're not working together at all. They're just doing things independently. So this rhythm would be a third degree atrioventricular block or complete heart block. Alright, so this one here, or pause the video course. Now, this one here, the top one, this is regular. we have a rate of about 300, 150, 100, so about 110, maybe 120. If we use the other method, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So about 110 is what we'll call the rate. P waves, yes, I think we do have P waves. Again, that comes with experience, and I could be wrong about that. It just depends on your justification, but I think that these look like inverted P waves to me, but they could be Q waves. Doesn't really matter because it will give us the same result. Our PR interval is short, if that is a P wave, and our QRS is narrow, so it's not originating in the ventricles. So with that, we could say that this is a junctional tachycardia. And that's because if these are inverted P waves, that's consistent with a junctional rhythm. We have a short PRI. And then the biggest thing, we have these narrow QRS complexes, which tell us this isn't some sort of ventricular rhythm. And if it's over 100, which if it's somewhere between that, like between the normal range of a junctional rhythm, but it's below 100, that would be accelerated junctional. I'm sorry, if it's above the normal junctional rhythm range, that's going to be accelerated as long as it's below 100. If it's a junctional rhythm, but it's above 100 in rate, that's junctional tachycardia, which is what this is. This next one down here looks pretty regular. We have a rate of about just under 300, so in the 200s. We have no discernible P waves. We can't determine PRI, but our QRS is narrow, so it's coming from above the ventricles. And with that, we could call this SVT, or supraventricular tachycardia, which technically isn't a rhythm. It just means that it's so fast we can't tell what it really is. This one down here, it looks a little irregular. It's right there. That's pretty short compared to like this one or this one. Our rate is about it's about 90. P waves, I would honestly say that there are no P waves. You could argue that this and that these right here are P waves. I'm not super convinced about that though. So I would probably just not call them P waves, and it is irregular. So with that, I would probably call this atrial fibrillation controlled. Alright, so that is the end of these rhythms. I might have some videos in the future, just very short ones going over 1 or 2 rhythm strips at a time, just for review purposes and just to show interesting things and break down why they are what they are, stuff like that. But yeah, we'll see what happens with that in the future. But for now, good job with the self-assessment part of this. If you got a lot of these wrong, or you didn't understand some of the stuff that I was saying when I explained it, go back to your textbook and reread parts that you were confused on, or watch the EKG crash course on this channel again on the parts you were confused about, and just keep working on that until you feel comfortable. Then try it again, and hopefully you did do well on this and you understood everything fairly well. And if so, good job, and you will probably do pretty well in your class, assuming that you did understand this stuff fairly well. And yeah, if you did good on this, then watch for the advanced EKG course to come out here on EMS Peers, and I look forward to having you watch that one. Have a good day, and thank you for watching.